Welcome to Better Health Guy Blogcasts, empowering your better health. And now, here's Scott, your Better Health Guy. The content of this show is for informational purposes only and is not intended to diagnose, treat, or cure any illness or medical condition. Nothing in today's discussion is meant to serve as medical advice or as information to facilitate self-treatment. As always, please discuss any potential health-related decisions with your own personal medical authority.
Hello, everyone, and welcome to episode 198 of the Better Health Guy blogcast series. Today's guest is Dr. Werner Vosloo, and the topic of the show is DNA adducts. Dr. Werner Vosloo is a naturopathic and homeopathic physician who focuses on and has a passion for helping people with chronic conditions heal through the use of natural and integrated medicine. In 2010, he started Restorative Health Clinic in Portland, Oregon, which has become a place of healing and hope for patients with multi-symptom chronic conditions. Wanting to improve treatment outcomes and decrease treatment time, Dr. Vosloo opened Restore BioClinic in St. George, Utah in 2018. In this dry, warm, and sunny climate, Dr. Vosloo created an environment where optimal healing can occur. And now, my interview with Dr. Werner Vosloo. Having myself done environmental toxicant testing from a lab in Germany called IGL and exploring the topic of DNA adducts in my own health and recovery, I'm very excited today to have Dr. Werner Vosloo here to talk with us about cellular health, environmental toxicants, and DNA adducts. Thanks so much for being here today, Dr. Vosloo.
Thank you, Scott. Nice to be here. Nice to see you.
Talk to us about your personal journey that led you to the obvious passion you have for the work you do today. Did you have your own chronic health challenges that were the catalyst for the deep dive that you've really taken into Lyme disease and mold illness and many chronic complex conditions? What led you to your deep passion for this work and also to your deep love of plants and natural medicines?
That's a big question. I was born in the normal way. I was born healthy, developed naturally, was reasonably fit and athletic until I wasn't. And that is a story I hear so often in our patient base as well, is that things were going fine. Things were going along just fine until this, that, and the other thing happened in a condensed period of time, and you never recover. And the details of that is, that drop-down menu is really long and extensive. But, backtracking, I was born in rural South Africa on a 9,500 acre ranch. I had the most fantastic playground in the mountains of the Drakensberg mountain range of northern South Africa, really immersing myself in nature in a very kind of undeveloped and rural area. I had this incredible blessing of having had real relationships with my grandparents, understanding what life was like in 1920 and 30 and 40, and then also had warm and wonderful relationships with the local African tribal people that lived in the area, which is a completely different culture, a completely different way of seeing yourself in relation to the world, really. So that, in a very kind of natural agricultural or agrarian context, gave me, I guess, a slightly different formative hand as compared to the average person that is born into mostly a metropolitan setting in the first world. Now, in South Africa at the time, you could go to medical school, or there was a near primary care level homeopathic medical school, and that's what I chose as the education. So 5 years starting at age 18 in a master's degree primary care level homeopathic medicine program gave me a very, very solid kind of vitalistic systems-based approach to medicine and, to health and illness. And then NCNM as a naturopathic doctorate after that in Portland, Oregon, kind of gave me a different idea how you can have more of a focus on the biochemistry of health versus disease. So I think it was really this organic progression of being born in the situation and time that I was, with the formative exposures and then the wonderful educational experience and opportunities that I was able to have.
How much of chronic illness is driven by our external environment, by environmental toxicants, maybe pesticides, chemicals, heavy metals, mycotoxins? Would most chronically ill patients even have a chronic condition if we didn't have such high daily exposures to environmental toxicants?
I think it is a very big part of the causation. We're living in a time where there is an unprecedented number of man-made and also indoor chemicals that directly and negatively impact our health. So I think it's a very complex thing because it's so much more than your recent or even in your lifetime's exposure. We're really talking about what is the exposure of your ancestors, from looking at cell biology and especially the epigenetics of chronic disease or chronic health. It seems like at the very least, you are what your grandmother and grandfather got up to in terms of the effects of not just environmental chemical toxicants on the germline cells and the switching of the gene regions in order to survive the circumstances that they faced. That can be transmitted from very clear studies, at least 4 or 5 generations down the line. So I think it's this incredibly complex, really ecological role that we play in the direct chemical exposures, but then you blend in, again, the unprecedented pace of life that we have, certainly compared to what I sketched out very deliberately in terms of my observation regarding the pace of life in rural South Africa. There's still time, So again, I feel like it's just an extraordinary complex thing. And it seems like that 20 to 30% of the population, that if you think of how many people, well, currently this is relevant in the long COVID context, it seems like it's about 20, maybe 30% of people that struggles with ongoing symptoms after the COVID. In terms of biotoxin exposure from Dr. Shoemaker's model, it's about 20 to 30% of people that acquire the SIRS or the immune-involved illness from mold and non-recovery afterward. If you look at models with regards to HLA genetics in the context of chronic infections, especially Lyme, it's about 20 to 30% of people that struggle with chronic Lyme after the initial inoculation. So it seems like it's this, just tying this idea together, it's a very complex, your genome in the environment with all the supporting and convoluting factors that play a role. That said, a lot of it is acquired. So with a deliberate eye and a steady hand, you can disacquire the imprints of the environment on your health.
You are definitely a deep thinker. That went even beyond what I was thinking in terms of the environmental toxicity. But having myself learned a lot from Dr. Dietrich Klinghardt over the years, I mean, certainly he talks a lot about the impact of even the Holocaust, World War II, those kinds of things, and how that is an epigenetic influencer of gene expression that certainly contributes to a lot of the conditions that we see today. So we may have to weave in a little bit about, in our discussion later, how do we then deal with or address or mitigate the impact of some of our ancestral traumas and toxicant exposures and stressors and things of that nature. If we think a little bit about the environmental toxicants that we encounter in our current lifetime, what are the ones that might be at the top of the list in terms of not only the health problems they create, the severity of those problems, but even the depth to which they embed themselves into our bodies, into our cells, and thus the difficulty potentially in getting them out of the cell, out of the system? Are we more concerned about mycotoxins or pesticides or chemicals or microplastics or metals or something else? What do you see as the most troubling environmental toxicant exposures?
I think you named most of what I see. And there's really 2 answers to this question: is what is happening inside the cells, and what are we able to see and test for? So again, rewind 20 years, mercury, toxic metals. That was at the top of the list of toxicants that we focused on. And then we started learning more. Basically, the laboratory support system for our clinicians evolved wonderfully so that now we can do not just urine toxic metals, but we can also test for mycotoxins in urine and also industrial toxins in urine. And that is what a lot of integrated doctors and colleagues focus on, and it's wonderful. But the newest addition to this line of testing is literally the testing of toxins retained inside the cells. And that does look like it is a different cocktail or a different blend of cellular uptake and retention as compared to what the body is able to eliminate and excrete for us to test in the body fluids. So I find that in natural medicine, integrated medicine, we are maybe disproportionately focused on the toxins that we are at the moment, which are plastics, glyphosate, agricultural toxins, but also mycotoxins, which we can now test for in urine and also with some antibody tests. But if you look at what's inside the cells, it's not always the same thing. You've got a different body compartment for it. And I find that exposure is sometimes the same as what we see as retained toxins inside the cells, and excreted toxins that we can assess in urinary toxin measurements is much of the time, but not all the time, different from the type of, for example, mycotoxins that we find inside the cells. So, I think it's a very complex question. I think depending on circumstances and the method of evaluation that you use, you will get different answers. At this stage, I strongly favor the assessment of body burden of toxins, cellular burden of toxins, which in my opinion is where the actual damage happens, with the intracellular testing of toxins.
We're going to talk a little bit more about some potential treatment interventions, but since you just brought up the whole idea of transgenerational epigenetic influences, we have these physical toxicants, maybe toxins, because some can be endogenous, some can be exogenous. When these are deeply embedded in our cells, might people be more likely to retain these toxins because of transgenerational traumas, conflicts? I know Dietrich Klinghardt has spoken about one patient where he was working on heavy metals and working on it from a physical perspective, and then did a mental emotional intervention working on emotional traumas and conflicts, and the lab saw the highest level of excretion of heavy metals that they had ever seen. So is the solution to a lot of these intracellular toxins entirely physical interventions, or is there benefit to working on the mental emotional realm that thus then allows the body to release these retained toxicants?
I think all of it, and it's different for different circumstances. If I can add to that, the transgenerational observations of epigenetic effects, I found a great study of the effects of DDT, basically agricultural exposure to DDT. And the study took it to, I think it's the F4 generation. So basically 4 generations down, you still had not the DDT in the cells measurable, but the effects of DDT on the genome, meaning the epigenetic footprints, and thus the genomic switching, meaning expression versus not, of gene regions, up to 4 generations down, with certain cases of starvation and famine in Scandinavian countries where they kept excellent records. In the 1860s through 80s, there were a series of natural events that led to periodic starvation, and that cascading effect is still present today. And then one of my favorite examples is back to World War II, in the winter hunger of 1944-45, we had the Dutch resistance putting up an admirable effort, and the Nazis didn't like that. So they basically starved out whole regions of Holland. And Audrey Hepburn was caught up in that as I think a 15-year-old teenager. And several times she almost died. They ate tulip bulbs, etc., that they ground into flour to survive. And she and her family almost died. And if you think of, some of her most spectacular appearances, Breakfast at Tiffany's or Roman Holiday, we think that from those near death from caloric stress, low caloric stress or starvation, is why she had this almost bird-like, near transparent bone structure and complexion. And so again, there's a difference between the epigenetic influence on the somatic cells and then also on the germline, because she ended up not being overweight her lifetime. She did end up having an earlier death in her 60s, I think, which seems a little early for her, potential. But in her children, if you look at other people or other families or bloodlines from that era, to this day, so many of them, the dominant percentage of them, have symptoms of a cellular milieu that is switched so hard to conserve calories and not burn them because they may not be food tomorrow. And the observation is that there is a significant increase in diabetes, obesity, high cholesterol, heart disease, etc. And so that's just from one factor, probably the stress, but most specifically, the stress on the genome to survive under extraordinary low caloric conditions. And so I also presented to you the transgenerational effect of DDT and other toxins, agricultural toxins. I found some studies that does highlight in, primarily agricultural families, the higher incidence of some of these same conditions, obesity, heart disease, and then neurodegeneration in terms of Parkinson's. That is certainly part of the direct chemical exposure, but transgenerationally, and we don't know for sure if it's as a consequence of the linear transmission of chemicals or exposure between different generations, but it certainly switches the genetic expression, and that switching is what gets passed on down the line for up to 4, 5, maybe more generations at this stage. So it's extraordinary. What we live today is the cumulative epigenetic programming of the germline, really, and it does include infections, toxins, psycho-emotional stressors. So I love that Dr. Klinghardt teaches it. And then again, with the epigenetic study of the footprints on the cell biology, we're able to now bring that into the clinician's office to a much greater degree. And the beauty of this is that it is pragmatic. It is clinically actionable in so many different ways. Because what we see is we study the cellular structures and we can see deviations from optimal. And whether it's as a consequence of toxins or psycho-emotional stressors, it matters, but for the clinician, maybe not that much, because you can see right in front of your eyes what you need to correct to get someone out of the survival response, which we talk about as the CDR these days.
It will be interesting to see what the transgenerational epigenetic effect is on future generations from the last few years of living on planet Earth with the pandemic. I have to think it's not going to be positive. And so with that, I think some of this conversation at this point sounds a little dire. So people hold on, because we will get into some tools and some hopeful things. We're not going to leave it here where it sounds like doom and gloom. So
oh yeah, absolutely. No, if I can just jump in there, we're talking about we're talking about a plastic situation. Plasticity is the word I'm referring to, not the chemical plastic, right? So these are acquired, the epigenetic effects, whether it's psycho-emotional, traumatic, mechanical is in a different category. That belongs mostly to own lifetime mechanical trauma. But the effects of toxicity, infections, inflammation, you can absolutely undo it, because as the environmental factors imprint and as an epigenetic influence that shifts the way your genome expresses in relation to the environmental stressors, if you show, and we can talk about this in a little bit later, but if you show the cells how wonderful life really is, you can disacquire and undo it. And then here's the beauty, Scott, is if you do it early enough, you can pass that on to your children and your lineage. So it is very hopeful. And it is very optimistic. It doesn't have to be dire, but as life goes, it requires action. You can't just watch it.
Definitely feels at times like it requires a lot of action, but I agree with you that I think there is a lot of hope. Let's talk about DNA adducts. What is a DNA adduct? I think most people probably will not be familiar with that term. Are these adducts actually attached to our DNA, to our mitochondria? What damaging or deleterious effects do they have on the body? And then do you see higher levels when you're doing this testing, the IgL testing? Do you see higher levels in sicker people as compared to healthier people? Or does everyone have very similar levels? Why do some people maybe have higher levels than others? We just talked about some of that. Is it potentially because some people also have less than optimal ability to detoxify, maybe overlapping in some way with methylation efficiency? Or is the primary driver of our level of DNA adducts really primarily related to our external toxicant exposure?
Some and all of that, if I can take it maybe from the last question back, it's a very complex interplay. And I'd hope that we can get to some of the intricacies later on. I think primarily in people that have a chronic, especially if it's a treatment-resistant condition, I do see much higher levels of adducts as a by far dominant observation, compared to sometimes we've got people with extraordinary symptom burdens and the adducts are not that bad. And then you need to go look elsewhere. Comparing as a general statement, yes, people that have clinical conditions where the body doesn't function and regulate well, the adducts are much higher, by 30-40% higher, as compared to the, not that many, but I've been able to, or I've had requests from people that have a healthy life. They don't have a symptom burden. They think they're normal in terms of health status, where the adducts are usually in the normal range, which, by the way, gives me quite a bit of confidence in the range, the reference range established by the lab, that I do see typically, with few exceptions, that people that feel healthy and function and regulate well, they don't have much intracellular toxins, but they do, but in compared to patients that have challenges. And then, in terms of your question, what is a DNA adduct? It is the definition is a typically exogenous, but it can be endogenous generated chemical that is covalently bonded and reacted into the DNA double helix, specifically into gene regions, or the regions adjacent to gene regions that controls the gene region. I'm talking about the gene suppressor and gene promoter regions. It used to be, we thought it was just nonsense DNA, just kind of placeholders, but it seems like they're actually really important. And if you think of the effect of an adduct on the gene promoter region, you're going to make excessive amounts of copies of a DNA gene region when you're basically pushing the Xerox button to make copies of whatever's on the machine, right? So thinking about what DNA adducts are is it's a chemical that is bonded into a DNA gene region. A DNA gene region is something that has a message. It's a set of instructions of how to, right? So the gene region for MTHFR, most people know what that is and does. The gene region for the vitamin D receptor, or COMT, or for, you name it, the detox system, blue eyes, blonde hair, things like that, right? So when you have a chemical covalently bonded into the structure of the gene region, it causes several things. So if you can think of just immediately the message or the operating manual instructions for how do you make glutathione, or how do you make GSTM, the enzyme that puts glutathione to work, that instruction is distorted and essentially heavily redacted. And if you think of what that means in terms of downstream, and maybe we can talk about that in a little bit as well, what does it mean for cell health, cell function, that transcription through to translation into the metabolome, proteome, lipidome doesn't happen as per, kind of wild type code? But at the DNA level, it means the DNA, you've got typically a single strand break from the bulky chemical adducts. And not only does it distort the DNA message, but it most certainly distorts the duplication of DNA with mitosis and meiosis. And that's where the transgenerational problems come in, where you have junk DNA with or without the chemical transferred to other cells. And in our lifetime, we're thinking neurodegeneration going into cancer. And on the longer timeline, we're thinking of junk DNA, non-functional DNA gene regions being gifted to our offspring.
What are some of the symptoms that might lead you as the clinician to really consider DNA adducts as a contributor to that patient in front of you? What conditions might DNA adducts be more commonly associated with? Or is this just something that every chronically ill person that comes into your office, that this is a key part of the exploration and the journey to getting them well?
That's an excellent question. I'm still figuring that out. But what I do know is everybody has adducts. It's just a matter of essentially how much chemical uptake you have that is interacting negatively with your genome. And then in relation to the work that needs to get done, so environmentally appropriate DNA expression, do you have enough reserve capacity to get the job done or not? So, for example, that looks different for a worker in a chemical factory where the detoxification enzyme system needs to be incredibly good, and you will have a dominance of expression of detoxification type gene regions, right? Now, if you decrease the appropriate and correct functional expression of those DNA gene regions by 30, 40, 60%, it may be below what the environment requires for you to not have a net tissue saturation versus the uptake is adequately compensated for. So to make a very complex thing short is, I think when you see in relation to people's genetic potential, if they were born healthy and they had a stretch of healthy life, normal health, and then they acquire a condition, that's where you definitely go look for it. Especially if they've done the appropriate lifestyle adjustments. They've seen 1, 2, 3, some of our patients have seen 50 doctors. And a reasonable amount of these physicians, I know them, and they do extraordinary good work. They're thorough. And that's when I know that there's something really important hindering the genome's ability to get the cell out of the CDR towards cellulogenesis. So I think it's when you see a discongruence between body behavior regulation and the actual symptom burden and level of health and vitality that someone has with what they're doing and what they've done. And of this, I'm certain that's when you absolutely need to go look for, at the DNA level, there may be a hindrance in the form of adducts.
How much of the severity of maybe someone's chronic Lyme disease, for example, correlates to their toxic burden? Coming back to the long time debate, is it the germ? Is it the terrain? And then do you see very many people with chronic long-term Lyme disease or other neurodegenerative conditions that don't have a significant toxicant burden, a significant DNA adduct burden, maybe from mold and mycotoxins, for example? How closely are these correlated?
There's a very, very close correlation, for the most part, with obvious exceptions, but the majority of people with a longer timeline of illness, with a higher symptom burden, symptom intensity, most of the time, they have much higher numerically measured levels of adducts and other cell organelle and membrane, essentially deviations away from what we consider optimal. That said, well, it's a two-way street. Sometimes we have patients that after the initial workup, we do see that the toxin levels are extraordinary. And after we have successfully healed those cells, they are not significantly better. And that's when most people come in having treated the Lyme at least 3, 4, 10 times with people that are extraordinarily good at killing bugs, right? So I don't always have to go for the great, you've got Lyme, let's jump on it, because that's been done by people that are so much more skilled at driving IV or other antibiotics than I am. So I have the freedom to go to places that haven't been investigated yet. Most of the time, when you get cell capacity to do their work back on Lyme, you've got this enormous amount of compensatory body systems, including immune system, that starts jumping in to do their specific work. White blood cells do their work. The liver and the spleen do their work, thymus, brain. So again, you just start seeing, it's kind of like when the tide comes in, all the boats start floating. So we've got a very, very significant degree of our patients that come in with clinical Lyme disease. Labs are positive, the symptoms are there. And by doing the cell stabilization treatment, meaning undoing the cell danger response with this epigenetic cell biology approach, the Lyme goes away and the bugs go away too, without needing any antibiotic treatment. Because it gets back to, remember my vitalistic roots of the body can take care of its priorities, but only when it's able to. So the average immune system should be able to take care of Lyme, and usually it does. And so this is a very complex interplay.
So we're really in this work removing the roadblocks to healing so that the body can execute on its innate blueprint of health. And I am curious, just as a clarification, when we say that then Lyme goes away, my thought process has always been that once we have Borrelia, Bartonella, Babesia, we probably don't ever fully eradicate them, but I don't think we need to fully eradicate them to regain health, that they can still be part of our microbiome. And if our immune system is working properly, that is essentially a non-issue. So I'm curious, do you think then that these things are really fully eradicated, or do you think that the body then manages them the way it was designed to?
Yeah, I love the way you phrased it, Scott. It's the latter, I think. It's basically, it's an ecosystem, right? And if the balance is there, you don't have to manually go and do the work on behalf of our compensatory systems. If we replace, and make no mistake, I absolutely take Lyme and all of the infections, I take them seriously because they are pathogens. But if we replace Lyme, Bartonella, Babesia with chickenpox, right? Most people that have had chickenpox, they don't live in imminent fear that they're going to get massive shingles outbreaks. It happens, but very, very rarely. And then there's usually reasons for it. And now let's replace the chickenpox virus that is dormant in your spinal cord with all of these bugs. And so it's about restoring a natural balance in an ecosystem with checks and balances.
It's interesting that you went to the chickenpox example, because I personally absolutely believe that I still have some Borrelia, Bartonella, Babesia. I don't think that has been an issue for me for many, many years now.
Yeah.
But varicella zoster is an ongoing issue. I've never had shingles, but I do sometimes get some odd sensations and things like that, and have very positive blood tests for varicella zoster virus. And so it's something that I continue to work through. To your point, sometimes we do need to address these microbes, but I also absolutely agree that if the body's own systems are not back online, if we still have these significant roadblocks to healing, working on the bugs is not going to get us to where we would like to be.
Exactly.
Let's talk a little more about testing for DNA adducts. I don't think most people, probably most practitioners, don't even know that we can test for these. We've mentioned IgL a little bit in the conversation, but talk to us about the DNA adduct testing. And then this could be a whole separate podcast, but what are the key pieces of information or commonly observed patterns that this IgL testing conveys to you? What do you see? What's important? What are you looking at in doing this testing assay?
I'm a clinician versus being a PhD academic, right? So I see things through how useful is it for the people that I serve on a daily basis, right? So the DNA adducts testing, or let's talk about the suite of cell biology focused epigenetic assessments that we can do through IGL. I think one of the most exciting ones is, in fact, the DNA adducts. It is a very simple blood test, and it's not that expensive comparatively. I think it costs 160 euros, if I remember correctly. And the sets of information you get from this specific DNA adduct assessment is really useful. First, the lab looks at the nucleated cells in your blood. So they isolate 10 million lymphocytes and then extract the DNA from that. And then from the extracted DNA from 10 million lymphocytes, they start looking at how much as a totality of the DNA in the, I imagine, vial is affected by DNA adducts. And that gives you a numerical expression of how much of the DNA is compromised. And you can't express that gene region or the information or the functionality correctly. And there's an optimal range that I really see as very correct in terms of when you exceed that amount of DNA gene regions that is compromised by chemical DNA adducts, you are above threshold, and the amount of gene regions that is compromised and you can't express it catches up with you in the form of some sort of clinical syndrome. So that's very useful as a bird's eye evaluation. And that's where much of the time you've got people that have a chronic condition have much higher levels of adducts, meaning much greater percentage of DNA is compromised and you can't express it correctly as compared to healthy people. The next set on this study is the specific DNA adduct, and these would be chemicals like organic mercury or formaldehyde, glyphosate, aflatoxin, and the gene regions that they're adducted into cell after cell. So again, we get this expressed as a numerical measurement of the, for example, micrograms or picograms per milliliter of aflatoxin on glutathione S transferase or similar gene. And so there's this report that basically tells us the specific gene regions that are compromised to a very high degree. And that's exhilarating for the clinician because you get to see a lot of patients with chemical sensitivity. There's a cytochrome P450 enzyme compromise, or GSTM comes up a lot, or in people with, for example, OCD or eating disorders, you see almost always BDNF, brain-derived neurotrophic factor, is compromised there. Or in the kind of the earlier onset Parkinson's cases that we've done this test on, there's a reasonable amount of one or other Parkinson's associated gene that is influenced. So that can actually be meaningful and validating in the clinical setting. And some of the time it just seems like, yes, it's more information and I can't see the clinical correlation with the gene regions affected. And it doesn't really change what we need to do anyway, other than the chemicals that were available to adduct into the genome. When you think of the DNA coiled around histones, right? If you think of in the kind of most of the time when the DNA is stored safely in the pantry, it's coiled up so tight and it's much protected, very strongly protected against chemicals from the environment gaining access to and reacting into it. But when the DNA is uncoiled for expression of gene regions, that's when they're much more vulnerable to forming adducts with the chemicals that are inside the cell in the nuclear area. And I think that's why I see such a preponderance of detox genes, for example, cytochrome P450 GSTM affected by it, because it's probably during the chemical exposure that those genes are uncoiled and exposed for expression that they get affected by the adduct. And that's kind of rubbing salt into the wound, isn't it? It's literally insult to the injury. So hopefully that answers your question to some degree.
Yeah, maybe one other piece that I would love to touch on is just tying it back a little bit to mitochondrial health, mitochondrial status. Are the adducts also directly impacting the mitochondria and thus our ability to create ATP and have adequate energy currency to support the healing process?
Yeah, very strongly so. In as much as the mitochondria does have its own separate DNA, it is absolutely affected by the adducts. The lab does report on that in the translocator protein study. They used to report the actual chemicals adducted into the mitochondrial DNA, which is usually similar, but not always, to what you see on the kind of the nucleus, the nuclear DNA. And it absolutely affects mitochondrial function. At the moment, it is reported as, I think, is there DNA adducts and are there fluorescent chemicals, so self-fluorescent chemicals during the microscopy assessment that they can identify in the mitochondria.
So we know these DNA adducts themselves are essentially epigenetic influencers of gene expression. Does having a predisposition in a SNP, a single nucleotide polymorphism, does that increase the impact of the DNA adduct on that specific function? Or do these DNA adducts affect gene expression regardless of predisposition?
If I understand your question, is if we have a gene that is classified as a SNP, if the adduct affects it differently.
Yeah. So, for example, if I have MTHFR 677, 1298, I already know I have some predisposition maybe to not detoxifying or methylating efficiently. Is the DNA adduct then more likely to have a more significant influence on that specific bodily function, or is the predisposition in the form of a SNP not correlated to the impact of the DNA adduct on the gene expression?
I don't think so, but leading up to it and following after it is where it really matters. So I think if you think of the cellular hierarchy, where you've got the genetics, which is where the qualitative study of the gene regions, the SNPs, come in, right? And then downstream from that, you've got transcriptomics, and then you've got metabolomics, lipidomics, proteomics, etc. Above that, and superseding the qualitative assessment of the DNA gene regions, is the epigenetic influence on the expression of said gene regions. So in the patients that I see, whether somebody has a SNP or not is totally irrelevant in order to effectively get them out. But so again, I used to know this field of study so well, and I used it until I realized for the chronic patients that don't respond, which is what I focus on, it just doesn't seem to be clinically helpful. For a lot of people, it's extraordinarily helpful, but for the patients that I serve, it isn't, because in as much as the qualitative assessment of gene function, which determines how well the body does flush out catecholamines or estrogen or toxins, right? So SNPs are very strongly correlated with whether you acquire the adducts, right? Because if you're not detoxing effectively, that balance that stays in the body does damage, and some of it goes towards DNA adducts, and then you're much more likely to acquire a chronic illness. And then during the state of chronic disease, if you are at a level of progression of the cell danger response that you have essentially, you're more in the survival phase rather than exiting in the cellulogenesis phase. If you take extra B12 or folate or whatever it is that is appropriate for that gene region, it doesn't seem to make an appreciable difference in exiting the cell danger response. And then following recovery, so basically after we do the cell stabilization treatment and we've removed the DNA adducts, that's again where the SNPs and related protocols, supportive protocols, become very important in order to retain the health that you've now regained in the context of your life with its exposures and stressors and sleep deprivation and whatnot.
It sounds a little bit like the chicken and the egg kind of situation. But what I liked there was what I heard was that the DNA adducts influence gene expression regardless of predisposition from a SNP perspective.
Yeah. So again, if you see a gene region as a page out of an operating manual, and if it's a set of good instructions to fix a problem or not, it doesn't matter, because that page is totally redacted. It's like I let my 6-year-old loose with his favorite green crayon on the page. And then that page goes to photocopying through to being the blueprint from which those proteins are made. And all of this happens faithfully. So if there is a DNA adduct that completely distorts the base pair coding for what does this code for, you have the mRNA copy being faithfully made of whatever is present in that gene region, that locus. So whether it's a SNP or not, it just doesn't matter, because whatever is in there is so highly corrupted that you end up making misfolded proteins.
We talked a little bit earlier about some of the environmental toxicants, the pesticides, the chemicals, the mycotoxins, and so on. When we look at DNA adducts from an IGL test perspective, what are the patterns of more common adduct types that you see in that testing? And might that lead us to specific changes in our behavior, in our exposures, in our detoxification strategies? What are you seeing as the more common adducts on IGL panels?
I see a lot of, it does vary quite a bit, but kind of looking at averages, I see a lot of metals, specifically aluminum and organic and inorganic mercury. I see very significant levels of mold toxins. I see agricultural toxins, specifically Roundup shows up a lot, glyphosate. I see a very significant amount of PAHs. It's a massive group of chemicals, but it's basically the products of combustion, right? The polycyclic aromatic hydrocarbons. I see an extraordinary amount of industrial toxins, especially toluene and related compounds. And then in specific exposures, whether it's breast implant illness or certain industries where people function, what comes to mind is a gentleman that worked in a wood and furniture finishing shop. And the amount of solvents from the lacquers and whatnot that they used there was just incredible. So I think it really is a varied platter. And that's the beauty of the DNA adduct test, is that you order this one test and basically what you're asking is which chemicals are on the DNA gene regions. And whatever is there is what's on your report. You don't have to do a report for, as a clinician, you say, gosh, is it mold toxins? Let's do a mold toxins in urine test. Is it toxic metals? Let's do that test. Is it industrial chemicals or whatever the case may be, right? Is you ask for what is there, and that's what's reported for essentially $160. So I think it's clinically so very useful to look at what is there rather than guesstimate how you're going to apply essentially the patient's blood and money, right? In order to get the information that you need to enable unhindering progress.
And just to clarify for listeners, the $160, that's a subset, one specific piece looking at DNA adducts, but then you can do all kinds of add-ons. I remember when I did my pre and post IGL testing, I think it was closer to $1,500 each time. So is that because the 160 is just the adduct piece, but I would say, are you commonly doing more than that to get a broader picture, or is that adequate for you to determine your clinical path forward?
It depends. So for baseline testing, because we have the ability here to test for general intracellular toxins, we have the ability to test for mitochondrial membrane structure, literally the specific molecules that comprises mitochondrial membranes. We've got the ability to test for metallothionein, superoxide dismutase, things like that. So there's this, a very, very reasonable menu of options to help assess. Basically, the question is, what's going on at the cell level that they're still committed to the CDR to maintain the survival response? So the costs vary. If you've done an adequate amount of treatments and you're not quite there yet, but you just want to do a spot check to see, are we headed in the right direction? Then you can do, for example, just the isolated DNA adducts test to compare and contrast with baseline.
These DNA adducts can originate exogenously outside the body. They can also be endogenous or originating from inside the body. So what are some of the exogenous sources to consider that might be less obvious? We've talked about many, but are there some that we might not commonly think about? And then when we think about endogenous, items or materials that can lead to DNA adducts. Where are those being created in the body, and what can we then do to reduce the endogenous production of chemicals that might contribute to our DNA adduct burden?
That's a great question. I think the majority of what I see is just very clearly environmental toxicants that got into the body and the system lacked the ability to detox and eliminate. Some of the toxins that does show up, which is, it's hard to say whether formaldehyde is manufactured because the body does generate aldehydes, including formaldehyde as a part of its metabolic processes. It's not possible, I think, to distinguish formaldehyde, whether it's endogenously produced or not. I think some of the more in the membrane terrain, the study of the products of oxidative processes is really important. The one measurement that is available for us clinicians now to study is how much malondialdehyde, MDA, which is a lipid peroxidation end product, is embedded into the mitochondrial membranes as well. So again, that is an absolutely endogenously produced short-chain lipid peroxidation end product. Clinically, it's extraordinarily relevant. So I think the stuff that we produce internally is a lot less relevant at this stage as compared to exogenously acquired or environmentally acquired.
So let's maybe talk about implanted devices, whether that's metal in a joint or orthopedic replacement, whether that's breast implants, like you mentioned earlier. Can those then be sources of toxicants that can become DNA adducts? And are there specific ones that when you see the report, you go, wow, this makes me think this might be a breast illness or a breast implant illness scenario? Or, hey, maybe we need to look at some of these orthopedic things, or maybe you have surgical clips from a prior medical procedure, or maybe you have hernia mesh or something along those lines. Can you take the IGL testing and kind of reverse engineer it to potentially identify sources in the body?
Yes, definitely. In many, but not all cases of breast implant illness that I've been able to do this assessment on, I do expect to see some sort of silicone species as a DNA adduct. And also then there's a really useful chemicals in cells panel that is wonderfully set up, as there's many different classes of chemicals. So there is a silicones in lymphocytes panel that I check for people where there is an implanted silicone device that we can literally study to say, because it seems like, again, it's about 30% of people with implanted silicone devices that get breast implant illness, right? So from that, we can, in compared to the 24 standardized panel of intracellular toxins, which is just this really useful combination of mold toxins, toxic metals, industrial toxins, agricultural toxins, etc. And then you can basically say, in relation to this one panel of almost ubiquitously available or environmental toxins, what do the silicones in the cell? And there's something like 50 or 60 different species of silicones that are present. So it's a wonderful evaluation. For metal devices, we do see titanium, and especially with braces, palladium seems to be a very, very common finding, which again, if you think of why do they put palladium in metal devices or in braces, it's because it is so durable and corrosion resistant. But it is counterintuitive to me that from such a small amount of metal, think of braces, right? That you would get really high levels of palladium as DNA adducts, or if you do a metals in lymphocyte panel. And if you think about it, palladium seems to be about on par as a DNA breaking agent as compared to platinum. Even in cisplatin, in the typically breast cancer cytotoxic chemotherapy drugs, they add mixed palladium into it because it breaks DNA maybe even a little bit better as compared to platinum. So, and then sometimes you see where somebody has 2 or 3 metal joints, hip replacement, knee replacement and such, and it just doesn't seem to be a problem. So I think it's this really complex mesh of, again, genetics, the epigenetic influence on the expression of the genes, activity levels, nutritional status, and so on, that determines whether the exposure translates into actually becoming a problem.
Interestingly, if I remember correctly, silicone actually was one of the ones that showed up in my IGL testing. Unfortunately, when we did the retest, it was gone because we did a number of interventions. But I don't know that I ever really identified what the source was. That was kind of a head scratcher at the time.
Yeah.
What role do DNA adducts play in terms of being the driver or trigger for a cell danger response? And if we then work to remove these DNA adducts, does that move people along in terms of their healing cycle from CDR1, CDR2, CDR3? What are some of the tools that you find that are helpful for moving people out of a cell danger response, out of a survival response, and back into a thriving response?
I think DNA adducts have a very significant role to play. And again, this is not in the original benchwork from Dr. Navio, because those are metabolomic studies of what's happening inside the cell. And based on that essentially philosophical construct, we can now understand what happens inside the cell, and studying the adducts give us a first-hand view of what's happening inside the cell. So I do see definitely a correlation there, but it's not just the adducts, Scott. It's, if you think about what does it take to acquire DNA adducts that overcome your cell's ability to engage the DNA excision and repair system that removes the adducts and repairs the DNA perfectly. That cell is usually pretty toxic. And so studying the intracellular toxins at the same time that you study shifts in cell membrane composition, at the same time that you study the mitochondrial study. There's another one called translocator protein studies. In English, the translocator protein is the part of the mitochondria that releases ATP into the cytosol of the cell for cellular use. But what it really tells you is, do you have enough mitochondria? Are they clumped together? You know, exactly the way Dr. Navio describes it in his research papers. So getting back to the question is, when a cell commits to the CDR, doesn't matter which phase it's in, it's pretty toxic. And it's compromised not only with DNA adducts, not only the compromise in not being able to access that specific DNA gene region, but being able to manufacture really useful proteins, which is the tools of that specific cell in order to fix the problems it faces so that it can exit the CDR. So what I find clinically, and this is not written up, but what I see in chronic case that we support in exiting the CDR is when you remove the DNA adducts, when you replete the cells with the key cofactors that it needs in order to activate enzyme systems that leads the cell to enable itself to do internal housekeeping the way it did when you were still healthy. When you remove the toxins out of the cellular milieu and you repair cell structure, and I'm talking about the cell membrane, the plasma membrane, mitochondrial membrane, etc., most of the time, that is enough to signal the cell, which is in itself, the individual cell is a highly intelligent, self-regulating entity, in addition to being enmeshed as a team player in all 50 trillion cells. When you've shown the cell the good life, it more readily exits the CDR. So I find that I don't pay attention like I used to the various phases of the CDR. The protocol that I do based on the cell biology information that I get from the lab enables me to do the work that the cell needs to do for it, on behalf of it, without needing that much active participation initially, so that we've got the cell in a decent state of repair. If it looks at itself and it looks at the environment, hopefully it's happy enough, that it feels safe enough, that it exits readily the CDR.
It's interesting because we're talking about then the removal of the DNA adducts, potentially moving us out of a cell danger response, but tying it back into what you brought up earlier around transgenerational traumas and emotional conflicts and things of that nature. I mean, one of the things that I've observed, and certainly in my own chronic health challenges, is, feeling safe in the world is an important prerequisite for moving back to health. And
Yes.
if because of transgenerational issues or issues in childhood, ACEs, things of that nature, if we at a cellular level really never felt safe, then
Yes.
doing work in that realm, whether it's family constellation therapy or EMDR, or I also think, though I don't consider it to be emotional as much, I also think there's a place here for limbic system retraining as well. And so it's interesting because I wasn't really thinking in the context of our original conversation that we were going to loop all of that in. But I love that you brought that in, because so much of what happened even before we were born can impact how safe our cells feel and whether or not they're willing then to more readily move out of a cell danger response.
Absolutely. And in this kind of highly focused, well, clinical focus that I have, we also have an extraordinary focus for the reasons that you just said on what does the autonomic, basically neuroception and neuroregulatory system look like in its function. I literally, on the first day that people come for a course of care, I do an assessment of the autonomic regulatory system and start to adjust that. Neural therapy is extraordinary, but there's a lot of other treatments for it. And I find that limbic system, there's a radically more effective, self-directed, in the context of wonderful guidance, limbic retraining system called the Primal Trust that was created by Dr. Kathleen King. And I find that extraordinarily important because it is so much more than an amygdala retraining. It incorporates numerous other just really useful psycho-emotional and other factors. And then one of the other things that is so useful here as well is with the ligamentous laxity that people get. We often have an unstable upper cervical segment, CCI. That is, again, in this specific patient group that I serve, it is disproportionately prevalent in maybe not causing the illness. So on the timeline, you may not necessarily discover, significant mechanical trauma or even EDS, Ehlers-Danlos syndrome, or hyperelasticity in a generalized sense. But that seems to really hinder the autonomic system. And then if you think just back on the effects of not just ACEs and life events, psycho-emotional events on amygdala function, but you think of the effects of just mycotoxins on amygdala function, it makes it change its volume and thus overfunction in the context of mold-associated inflammatory responses. And just that is enough to keep you stuck from a neuroregulatory perspective in the CDR. So I guess it is complex, but all of it is acquired. And with appropriate focus and determination, you can disacquire it.
Or even the impact of mast cells on the amygdala and limbic system, right? They play a key role as well. Interesting that you brought up Dr. Kathleen King. That's actually the podcast I'm currently preparing for.
So that's going to be a very, very useful podcast. She's extraordinary in her having focused on this and having created a very clinically useful program.
Is there a connection between DNA adducts and cancer? And then extending on that, does reducing DNA adducts potentially reduce our chances of later development of cancer in our lifetime?
So the former, absolutely. At this stage, more than half of research papers from 1960 through to now is focused on DNA adducts in the context of DNA damage leading to mutations, leading to cancer. The opposite, I'm not aware of a single study that's been done to demonstrate that when you remove DNA adducts, that it leads to a decreased incidence in cancer. Somehow I think the funds for a proper study in that nature may not be forthcoming soon. It may significantly interfere with the oncology world the way it is.
While there may not be a study, the answer seems somewhat obvious, though.
I think so. I get so happy when a reasonably well and healthy person, that maybe it's a spouse or a partner of an actual patient, also wants to do the IGL cell biology assessment. And when we do see some color, with adducts or mitochondrial membrane changes, that they want to do a series of treatments in order to reverse the epigenetic insult, be it toxic or other, to the cell, because that, in my mind, is the absolute risk reduction strategy for chronic illness, degenerative illness, cancer. So I think so, Scott, but I don't have any, proper research that I can present to you to firmly demonstrate it by the standards that we are held as physicians.
That's okay. This podcast is not double-blind, placebo-controlled, so you're
Right.
welcome to share your clinical observations.
Logic holds that. Absolutely. There ought to be a very, very significant reduction, to the point that it would be just bad luck if somebody gets a chronic illness or degenerative or oncologic illness after having gone through the epigenetic reset.
Let's talk about some of the things we can do to minimize DNA adducts over time, both in terms of avoidance and how to support the body so that we're removing more toxins at a higher or equal level every day to what is coming into the body. And is there a place for binders or coffee enemas or colon hydrotherapy or other tools in the detoxification realm that you think clinically can really make a difference in minimizing the accumulation of DNA adducts over our lifetime?
All of it. I think there's several components to it. So if you think of managing exposures as of primary importance, and I think that's probably one of the easier things to do up to a point. And then the next set is to have the body be much better equipped to be able to process and eliminate acquired toxins. Because it is that balance of what you acquire, but you can't process, detox, and excrete that settles over time as tissue toxin burden. And that's what causes the adducts, because they're there. At the cell level, you need zinc in the nucleus in order to activate the DNA excision and repair enzyme system, which is what removes the adducts. Well, it identifies them, removes them, and then repairs the DNA. And then the adduct is gone. But it's not that simple because, for example, during the pandemic, I was doing this study before, during, and now after the pandemic, and patients coming in fresh for the baseline study, zinc levels were low, no matter if they were taking oral zinc or not. So I think it's a little bit more complex, and maybe you need to take the right type of zinc and enough of it. But I think it also is about literally when the cell is committed to the CDR, zinc doesn't have a place in the playbook because the cell wants to survive, and that means sick behavior. So again, part of a successful cell biology focused strategy is to enable the cells, or really trick the cells, to uptake zinc more effectively. And I'm kind of hoping you won't ask what it is, because it's still a work in progress. I think it's really complex. But in the entirety of what we do, we very reliably are able to increase intranuclear zinc levels to a normal and optimal level. And it seems like that is the key factor, is intranuclear zinc. And I think the SNPs or not, and managing the biochemistry behind the SNPs comes in very well here. And then digestive tract microbiome factors are really important with regards to the elimination or the recycling through bile reuptake of excreted toxins. And that's where the binders and colonics and whatnot comes in. And then I think most certainly autonomic innervation, specifically the autonomic function on the liver and bile flow and digestive tract, is extraordinarily important here. It's as simple as the parasympathetic or rest and digest autonomic nervous system. It promotes bile flow, digestive tract in its entirety, secretion and movement. And that's how you get rid of toxins, by secreting and moving it out. Whereas if you look at sympathetic or fight and flight system dominance in an unrelenting way, you have literally, it slows down bile production and it slows down GI secretions and motility. So again, it's a really complex equation. So hopefully that answered the question in a, well, as simplified as I can present it to you just now way.
So that ties in the last part that you were talking about with the parasympathetic support. That ties into supporting or tonifying the vagus nerve. Wondering if you have found any favorite tools, vagal nerve stimulators, anything that is consistently helpful for your patients in really calming the autonomic nervous system and supporting the vagus nerve.
Yeah, I think the vagus nerve is really helpful. Well, you can't have this discussion without paying due homage to the vagus nerve, right? But what I'm seeing is, if I can use a car model, if you think of the brake pedal, gas pedal model, if we can have vagus nerve being brake pedal on fight and flight and whatnot, and fight and flight is the gas pedal. In the car analogy, if you are pedal to the metal in the gas pedal and you're running a fight and flight response, pumping the brakes may or may not be useful. You need to get your foot off the throttle in order for this. So what I find is that the fight and flight response is immensely more dominant as compared to a attempt from the parasympathetic or vagus to get some airtime in determining how organ systems are regulated. So I do all sorts of vagus nerve encouraging techniques, and in the clinic, just because it's simple, it's easy to do. I have patients do every day that they're the CES Ultra device, which is just a little vagus nerve activator that you clip onto your ears. It's got for lack of better words, a volume control, so people can adjust it to a level of comfort. And I think it's useful. But what I find even more useful is to, in very, very clear, practical terms, get the fight and flight to back off.
So the way I interpreted what you just so elegantly said was the vast majority of people with these complex chronic conditions are type A personalities.
Sure, either by birth, by example, learned, or just life has not been too terribly kind. And it in some cases, it's purely just, it's an acquired fight and flight upregulation without being able to readjust down towards situationally appropriate balance with the parasympathetics.
I am a proud type A minus personality now. Thank you very much.
Well done, because it takes time and really hard work to disacquire that sympathetic dominance.
It's still there. But the other thing that popped into my mind is just another correlation was you talked about the importance of zinc. In so many of these conditions, we see cryptopyroluria, which is a zinc deficiency condition. And so I would suspect then that those people that have untreated KPU have less zinc and thus more likely to continue to retain these DNA adducts.
I totally agree. It really doesn't help, right?
Yeah. The other thing, since you mentioned the pandemic, I mean, this is just such an amazing conversation. I'm loving it. But you mentioned the pandemic, wondering if you've had any correlation between those that develop long COVID and those with high DNA adduct burdens.
Yes and no. It seems to be reasonably balanced. So obviously with the epigenetic cell biology lab, we can't check for viral particles or antibodies to the spike or the spike. What we can see, though, is cell structure shifts in relation to the stressors that the cells face. So a lot of the time we find disproportionate oxidative stress markers in people with long COVID. And then again, it is actually really well represented in the literature that acute COVID versus long COVID, they have tremendously elevated levels of specifically malondialdehyde. And very interestingly, in patients that succumbed and died from the COVID, their malondialdehyde levels were lower as compared to patients that survived and now have long COVID, right? No, these are people that were really sick in the hospital, right? And it shows that the more your cell is able to, as a part of the CDR, in the appropriate acute heat of the moment, to produce tons of oxidative molecules, those are the ones that actually make it. So it's a very interesting thing. And then on the other panels of the IGL test, we find, again, it's a balanced combination of toxins, but almost always we find on the analysis disproportionately high mold toxins in the cell and as DNA adducts. And most of the time you find that in the history, temporally, there is mold exposure or a current moldy home. And I've spoken with some of our colleagues, and they agree that they do see a predominance of mold illness comes first, and the immune challenge and everything that the symptomatic COVID brings to the table exacerbates that.
Let's talk a little bit about some of the IV therapies that can potentially be used to support removal of these DNA adducts. So I'm thinking here of IV phosphatidylcholine, for example, and wondering what are some of the ingredients or materials that you're using in your clinic in these IVs? Is it based on the work of Dr. Patricia Kane? How many IVs might the average patient need to go from a baseline IGL to one that documents significant improvement or removal of these adducts? For me, it was 54. And then I'm wondering, can we get there with oral interventions alone, or do we really need to be looking at IV therapies for DNA adduct removal?
Let me start at the beginning of the string of thought. The Dr. Kane's work has been invaluable for me to understand the importance of tending the membranes in the context of illness. Her work was, to my understanding, I studied under her, and the foundational experience is an understanding that the cell membranes are extraordinary, the plasma membrane. It's extraordinarily important in how things play out and also reflective of what the cell is up to. Now, with the addition of the IGL cell in its totality biology study, we needed to add a few extra things. So there are components of Dr. Kane's protocol in there, which I think is wonderful. And then with the German mentors that I had that immersed themselves in this for about 20 years now, I think, there's other nutrients that need to be incorporated in order to tend key enzyme systems that functions in the cell regaining the ability to autonomously, I call it housekeeping, cellular housekeeping that needs to be done. So again, the protocol is quite a bit different as compared to the PK protocol. Some of the other therapies that are really useful is, like we spoke about, zinc is an essential part of this protocol. And I've hopefully explained sufficiently why. Manganese is extraordinarily important here, not just for the superoxide dismutase antioxidant systems, but one of the key enzymes in mitochondrial membrane repair, the inner membrane, that manufactures cardiolipin, which is one of the unique phospholipids that gives the mitochondria its very unique, highly folded membrane to increase the surface area so that you can, in a very, very small organelle, have this very, very kind of folded and stacked membrane to create an enormous surface area for energy production. Manganese activates the cardiolipin synthase enzyme. So again, manganese is fundamental in mitochondrial recovery. And again, based on the patient, there's several nutrients that we introduce or have more or less of, depending on clinical presentation, current sensitivities, and so on.
How many IVs on average would you say you have to do to adequately remove DNA adducts, and over what period of time is that? What is the patient committing to?
It's usually about 20 to 30 treatment days in clinic that we need. And again, it's all over the board. A 17, 19-year-old patient that got COVID and now has long COVID, they typically don't need that much treatment, or that had Epstein-Barr and they're 2 years into chronic fatigue syndrome. It doesn't take that much. a 75-year-old person that has smoked, 3 packs of cigarettes a day and they've had cancer and chemo 3 times, that's a totally different picture. Based on clinic average at the moment, it's for the chronic patient that has a multi-system involved, multi-symptomatic condition that is treatment resistant. It's between 20 to 30 treatment days, with the balance being closer to about 30.
And would you say that some IV intervention is generally a requirement for this type of protocol, or can some patients remove DNA adducts with oral interventions?
That's a great question. Mostly in the clinic, we work with people that opt into our intensive care program. And we do have a reasonable amount of patients that, for whatever reason, we didn't go into doing the IV protocol. We do have at this stage, I've been whittling away at it for 6 years now, a pared down, very manageable cell stabilization oral protocol. And it seems like there's a few factors, The protocol works. We do have wonderful examples where the oral protocol may work as soon as, 6 to 9 months in helping to undo the chronic kind of stuckness of the survival response. But that said, the oral protocol is only as effective as the digestive tract is at help at absorbing the nutrients into the hepatic portal system. So all of it goes to the liver first, well, with the exception of much of the PC that absorbs directly into the bloodstream. And then it's only as effective as the immune system allows tolerance for nutrients, thinking of the more sensitive, more reactive system. And then also, it's not guaranteed that the liver is going to share the nutrients with the systemic circulation. There are some interesting studies, kind of, basically nutrient kinetic studies, that says that even for the phospholipids, in certain instances, the liver hogs about 50% of it, orally administered phospholipids. So, long answer to a very focused question. The oral protocol is good, and a lot of people respond to it. But again, personally, when I was still kind of stuck in the CDR, after about 12 years of that, I tried the oral protocol. And maybe I was impatient, but after 3 months, I didn't see the needle move at all. And I opted into the IVs, which really helped me.
Many of our listeners, being people that have had some chronic Lyme component to their health history, will question or have the question about manganese. We know manganese essentially is feeds Borrelia. So I'm wondering, in those people that you're working with that have Lyme, do you find that before you start repleting manganese, that you have to also make sure something is on board to kind of manage the Borrelia component, or do you not find that to be necessary?
No, remember that magnesium feeds Babesia. Remember that Babesia is a big, sophisticated organism. It thrives when there's phospholipids in the body. So again, I find that, literally you're going to cut your nose to spite your face, right? So again, as an ecological exercise, a study of the ecology in the body, I find that when you bring all 50 trillion cells of the body on board, and you have the specialty cell types starting to reacquire their ability to contribute what they can do for the body and for the recovery process, that's generally the messaging I get and my observation. So I love the question, but there's actually some research that says that when you give Borrelia manganese, they relax because they get what they need. And they're much more aggressive if there's a manganese deficiency state. So again, it's an interesting discussion, and I don't find it useful to tap dance around that.
If I remember correctly, the PK protocol primarily consisted of phosphatidylcholine, glutathione, sodium phenylbutyrate, and leucovorin. Wondering if there is a place for sodium phenylbutyrate in this DNA adduct conversation, or if that is not necessary or not helpful.
I think specifically for the DNA adducts, probably. It does, so butyrate as a microbiome postbiotic product that absorbs into the body has a very important role to play, not just at the cell membrane and basically the cellular machinery. In terms of removing DNA adducts specifically, I don't think so. But in terms of cell membrane structural begets normal function in transporting nutrients in and releasing toxins? I think yes. And then in terms of the cell biology recovery, it's extraordinarily helpful.
Once someone has done a series of IVs and you repeat the IgL testing, does it generally show improvement? And how often does that improvement correlate to how the patient feels clinically?
Most of the time, a very strong correlation between the numeric level of reported adducts and symptom burden and sense of well-being, how you feel, how you function. So most of the time, after an appropriate amount of treatments, and that's debatable how much that is. Contextually, it varies from patient to patient. It's about the number of treatments, but also about the milligram amount of phospholipids administered, which is what really changes things. So the decreasing DNA adducts over time, it's typically congruent with the amount of treatments done, the milligram amount or gram amount of phospholipids in the context of the protocol administered. And then with retesting, there's oftentimes we are able to remove the adducts sometimes before there's real clinical improvement, which is oftentimes very interesting because if you look at the recovery of membrane architecture and DNA adducts and replacing the key cofactors intracellularly, you're oftentimes 2, sometimes 3 months ahead of schedule for when the patient symptomatically starts feeling better. Now, I just want to qualify it. Usually when the DNA adducts are gone, much of the positive symptoms, the symptoms of pain and IBS and headaches and insomnia are gone, but there may still be fatigue and, just that chronic blah factor. So in the clinic, I make this very clear distinction between you may not be feeling that much better, but you're certainly feeling less bad in terms of the symptom burden is reduced. And I think, just back to think of the hierarchy in terms of genetics into transcriptomics, into translation, into the actual proteins and enzymes and, things that is manufactured inside the cell. You make about 2 to 3 months worth of proteins. And if we snap our fingers and we clean the DNA and repair the cell is still full of 2 to 3 months worth of junk that clutters up the works. And that you need to just accommodate for the half-life so that there's a washout time in the intracellular, essentially the cytosol is gel. It's a gummy matrix. And again, so it's like walking through molasses, right? So sometimes you just need to have an appropriate wait time for the cells to catch up with how good they look on paper.
After someone has done a series of these IVs, does a retest with IgL, things look better. What does maintenance look like? How do we avoid reaccumulation of DNA adducts over time? Do people need to do an IV or two every quarter, or can they then maintain their improved state of health without ongoing IV therapy?
Sure, that's an excellent question. It varies quite a bit because for some people, a reasonable amount of people, it means when we've helped the cells to reacquire their ability to do their work. Next is, for some people, a lot of people, they just feel better. They function better, and the immune system is able to take care of business. Same with detox and sleep, day-night rhythm. For a reasonable amount of people, it means that now we need to reassess the status of systemic infections, chronic infections, parasites, things like that. And oftentimes we need to engage with that while we maintain the cell biology. For some people, is they need to see very specialized physical therapists, chiropractors, injection therapists to stabilize an upper unstable segment, and so on and so forth. For some people, it means they need to do limbic system retraining. But as far as the cells are concerned, that part of maintenance entails phospholipids and usually some appropriate detoxification blend. And again, I don't prefer to use in the oral protocols just glutathione. It belongs in the hepatic phase 2 detox system where you conjugate toxins that have passed through phase one with a large, bulky organic molecule in order for it to be, well, less harmful, but to be flushed out as well. And again, there's more than a handful pathways. And glutathione is one of them, glutathione conjugation, but sulfation, glucuronidation, methylation, those are really important. So I support all of those pathways and do some phase one, reasonably selectively phase one support. And then also, for example, I do reasonably high dose biotin because the enzyme systems that prepare fatty acids from diet, either for metabolism or for the immune system as signaling molecules, inflammatory chemicals, or for membrane components, so structural repair nutrients, require, again, zinc and biotin are the two most important cofactors there. And then in the context of typically from a diet perspective, as close as we can get to no sugar, which is a bit of a challenge, very low carb, and then mostly healthy repair nutrients, which again, it's protein and healthy fats. And then whatever else they want to eat that is nutritious and filling, doesn't irritate their immune system. And that's quite varied. So again, there's definitely a lifestyle diet, but also a very focused nutritional regime that we do as maintenance.
What do you consider reasonably high biotin?
I like between 4 and 5 milligrams per day. So again, I like what we spoke about earlier is that, sometimes more is not enough, but that's when you're usually in the more dynamic part of the cells does still have some ability to respond. With the cell stabilization work that we really reviewed well, I think, you need a few wheelbarrows full of phospholipids in order to repair cell membranes. The math is really quite humbling. It varies, estimates, but, 50 trillion cells in the body with an average of 500 mitochondria per cell. Cardiac cells have 5,000. There's a guesstimate for certain of the long kind of spinal nerves that they may have as much as 2 million mitochondria per, neuron. So again, the scope of this structural remodeling job, and I really mean that in the literal sense. The way that you renew a house is that you need a very substantial amount of repair nutrients in order to get the job done satisfactorily.
You have deep experience with homeopathy, which is often very helpful in supporting drainage. From Dr. Klinghart's work, I'm a big fan of extracellular matrix and looking at drainage remedies, things like Picana, Energetics, DesBio, many others out there. Is there a place in your work for homeopathy and supporting our bodies against the onslaught of toxicants and toxins that could later become DNA adducts? Does implementing a drainage protocol help to minimize the later accumulation of DNA adducts?
I think so. What we're talking about is signaling the cells in the specific organs to do what they're doing slightly differently. And then so what I favor for our chronic patients that seem to not be able to have as vital a response as you would get to, single remedy homeopathy or the French pluralistic system, the German polypharmacy formulas seem to be very well suited. So you've got what I use is two different types that I find helpful. I get good mileage with exceptions from Picana, organ-focused remedies, and then also the PCHF in Oregon. They are a little bit softer for the sensitive patient, and I get decent responses, again, from a cell and organ function alteration and support perspective.
ECHF is the same as professional formulas, right?
Correct, yeah.
Yeah, okay, yeah, I like those as well. Love drainage remedies. I don't really understand how some people can have a optimized protocol without drainage. And surprisingly, it's a piece that many people don't have in their protocols. I was very fortunate to have learned very early on. In fact, the acupuncturist that first identified my Lyme disease in 2005, that was her gift and passion, and looking at German homotoxicology and drainage and all of these pieces. And I feel like that was such a gift for me to learn early in my own recovery process, because I honestly am not sure that people can readily recover their health without a focus on drainage.
I agree. And again, the homeopathic medicines, as much as it's my first love in medicine, right? It is a means to an end. And that messaging that is not coercive is so valuable to help the cells take more responsibility for the specific specialty work that they owe the organism with regards to the recovery process and also maintenance. So it's absolutely wonderful.
And you still light up when you talk about these things, which I just love. I can tell your passion for helping people is very deep. How important are pure air, pure water, and pure food in terms of avoiding toxicants that may result in DNA adducts? And what do you see as the priorities for your patients in that avoidance of incoming toxicant exposure realm?
I think it's the ideal, isn't it? To be able to live in a pristine world where we're sheltered from, these negative influences. So as much as I am able to, I pay a great deal of attention to this. But again, I do think it belongs very strongly in primary care. So a contribution that would be so helpful to the medical system is essentially educating people in everyday families that are still healthy while they're doing their jobs, while they're going to school, while they're raising their children, to be aware and conscious of this, so that we have less patients, so that we have less people that are at a threshold for incoming environmental toxins that is above what they can deal with. And then, unfortunately, I see a very, very specific group of patients that have fallen ill, have not been able to recover, have seen, because my referral network are mostly clinics that focus on chronic Lyme, chronic mold, and I get referrals for people that don't respond to the, just really good integrated medicine protocols. So I do a little bit of focus on that, but I'm very certain that if primary care networks and education systems factored this in, that we would have an incredibly different chronic disease landscape in the medical environment.
If you had told me 10 years ago that I would only today be drinking distilled water, I would have thought that was crazy. And yet today I'm only drinking distilled water. Of course, I put minerals and all of that kind of stuff, and I structure it. But I used to think that was like actually really bad. And then you realize like there really isn't another way to get significant amounts of toxins. Sure, there's reverse osmosis, but I think distilled in terms of toxicant removal is even a step further.
I think so. It's such an interesting kind of trade-off for opportunity cost, right? Yeah. Where in order to get, so you get water out of the Rocky Mountains because you're in Denver, Boulder area, I think. Mm-hmm. And, we're at the southern end of that. There's a reasonable amount of not just aluminum and arsenic, but also radioactive metals in the water out of the Rockies, right? Just the way it comes. And when you remove that, you do have to do this additional tap dance to adjust the pH, because it comes out about 5.5 mm-hmm. out of the RO system, and then add the minerals back in. So it takes work and focus, I think.
We've kind of touched on this, but I think I'll ask anyway. And that is, some people suggest that many health problems result from chronic nutritional deficiency. Others suggest that it's more toxicity that's the main problem and nutritional deficiency is secondary. Wondering what you've observed in terms of toxicity versus deficiency in terms of their contribution to chronic illness.
I think it's both. It's an interplay and case to case. It's rare. In South Africa, where I'm from, nutritional deficiencies are much more real because it's the third world and people are fortunate to have food to eat, period. So here in the US, I find that it's literally this interplay between maybe key nutrients that are deficient, or in the context of their exposome, they run out of or use up key nutrients that fuel their ability to survive and have homeostasis in the context of exposure, where the person next to them that maybe eats a little bit more meat for the taurine, carnitine, and iron and B12 that they get from there, or the person that has a more efficient array of SNPs. So I think it's a very complex issue, and it's impossible to separate, right?
Yeah, I agree. As I, asked the question and then thought more about it. I mean, my initial instinct was to say toxicity is more important than nutritional deficiency. At the same time, if we look at the absence of trace minerals, then we know we are more likely to retain heavy metals as the next best thing. And
Yeah.
even in some heavy metal detoxification programs, repleting the body with trace minerals can be very, very helpful, because then the body no longer has a need to retain the metals. So I
Okay.
agree with you. It's another chicken and egg kind of scenario.
Absolutely. Yeah. I mean, you literally just have to pay attention to these really important things in order to get the exit from the sick response.
How important is looking at lipid balance in supporting health optimization? Talking about omega-3 versus 6 versus 9. Do you do the red blood cell fatty acid testing in your practice? What do you see in terms of patterns with your patients? And what are some of the strategies that you then implement to bring a more optimal lipid balance to our system? And then maybe I'll just extend on that a little bit. There's a lot of popular people these days talking about the toxicity of linoleic acid and how it should be avoided at all costs. I personally disagree, and I'm wondering what your thoughts are.
It's a big question. So I do pay attention to it. I think it's very important, all of what you said. So in terms of recovery, I'm a farm boy, so I try to keep things simple for myself. So in terms of what I see in people that have a chronic condition, especially if there's oxidative substances, and it's a very long list from mold toxins through to toxic metals, in the context of a lack of intracellular zinc, the antioxidant systems doesn't work that well, manganese as well. And then with disproportionate oxidative signaling from the cadmium and aluminum and aflatoxin and whatnot, what I find that starting off when the body is still key nutrient deficient and there's an excess of oxidative type substances and the antioxidant enzyme systems haven't come on board yet, because we can test those to see in what state of repair they are, I find that it makes much more sense to shift to a predominantly saturated fat diet in order to have less oxidation at the cell level. And I think it works. You get membranes, plasma membranes and mitochondrial membranes that are much more densely packed, much more resistant to oxidative stress, and thus the formation of these incredibly toxic, inflammatory, and, quite frankly, carcinogenic chemicals as a consequence of oxidation. That said, the brain, the immune system, the cell membranes, they just don't function optimally if there isn't some omega-3 and to a lesser degree omega-6 available. So these are necessary. And it's one of those things where at which stage can you start shifting? So I think for at least the first 6 months, give or take, it's very important to shelter yourself from the more unsaturated fats that can cause tremendous damage. So here's a very kind of close to my heart example, because I struggled with it. When I learned the cell membrane therapy first, giving patients a combination of 4-to-1 omega-6 to omega-3 plant oils was part of the program. And it made sense. We need those for, from neurologic function through to immune system, through to hormones and cell membranes. And I noticed that I really struggled to get the oxidative molecules, malondialdehyde, out of the membranes. And I thought that's just how it goes. And that was for my personal recovery as well. Malondialdehyde at some stage was the only problem left, because I was drinking omega-3 and 6 plant-derived oils. And then I realized what I was doing after I started really studying what does oxidative processes in the absence of antioxidant molecules, a redox system that is underpowered, and also, the key nutrients that fuels those antioxidant enzyme systems. And I completely dropped the omega-3s and omega-6s from my personal and also treatment protocols. And we had no problem with the oxidative molecules afterward. They now leave at the same time that we see the membranes recover and the environmental toxicants leave. So I know for a fact from these, basically I discovered that in about year 2 that I was doing this program, that we've got an issue here. And again, it's context, right? So I think from the work of Dr. Robert Rowan and another doctor that is an engineer, help me with the name.
Brian Peskin.
Thank you. That wrote the Parent Essential Oil Solution, PEO, I think the book is called. I really enjoyed the information in the book because that also guided me that we need those oils, but very little of it usually. So again, it's an interesting thing. I find that people do recover better if you pack their membranes with saturated fats. And it's still up for debate, when is the system recovered enough that you can start adding in a more, shall we say, free and easy balance of the seed oils or omega-6 oils in the diet.
Wondering if you have incorporated any of the work with plasmalogens in supporting cell membrane health, the work of Dr. Dayan Goodenow. Any thoughts on combining phosphatidylcholine, for example, with the plasmalogen precursors?
Yeah, you can't separate them. They're so close together, the plasmalogens and the various phospholipids that the cells need. I find that really it's about the plasmalogens, but it's really about the peroxisomal function. And, it's really the underappreciated hero of cell biology are the peroxisomes. And at this stage, I really admire Dr. Goodenow for the work that is done and for the education that he's doing in the community, the testing that he offers to help us assess peroxisomal function. The plasmalogens are incredibly useful. The plasmalogen therapy is an extraordinary innovation and contribution to having the cells do better.
Yeah, I'm a huge fan of Dr. Goodenow's, and I personally fairly recently did his prodrome scan as well to get a sense at, his way of looking at prodromes of health and disease. And I think it's another very interesting test with lots of applications, different from, but maybe complementary to what we're talking about here with the IGL testing as well. And then my next interest, he just this week released his egg yolk derived PC product that then is combined with the plasmalogen precursors. And so it's getting very fancy.
Oh, it's wonderful. He spoke about that maybe 3 years ago, this egg yolk derived PC. And you know what the most important concept there is? It's saturated phospholipids, right?
Yep. Yeah. You have created a company called Return Healthy to really empower people's wellness, their health. And you have some really amazing products that you've formulated over the last few years. My personal favorites are the Binder Blend, the Cryptolepis Synergy, the Cryptolepis Concentrate. But I know there's others in your treasure trove that I probably need to know more about. So talk to us about what you've created with Return Healthy and what are some of your personal favorites?
Return Healthy was essentially an unintended baby we had along the way. We started it in about 2010, and I just started getting frustrated within the patients that I serve with chronic illness. Most of them needed adaptogenic type herbs and also immune balancing, boosting, and anti-inflammatory herbs. And you end up just tending that with 2 or 3 different combinations of things. And I looked at the intersection between the herbs in these groupings, and I put adaptogen immune together as a single formula that is obviously not unique in that it's specifically made for one person, but it's made for the group of people that I serve. And most of the time, it's applicable as an adaptogen, an immunomodulator, and an immunostimulator. And so, fast forward a few years and we ended up having, 3, 4, 5, 6 different formulas that our patients were using. And we started getting requests from sister clinics that did the same work, that liked the formulas because we did shared care situations often. And we started getting requests for clinics that want to stock the supplement. And, so basically that has evolved into the formal Return Healthy, that we now actually have the supplements available both for clinics and physicians, but also for retail. The philosophy behind it is to simplify things. specifically for people that have this incredible supplement burden, is to, in a clinically appropriate, patient-centered, condition-centered way, combinations of nutrients that is either purpose or organ or task specific. So it really balances out for example, the companies out there that makes incredibly precise formulas. There's several companies like that have formulas for Bartonella or Babesia or Mycoplasma or HHV6, And I looked at that and I thought, but every patient I deal with have at least, 3 to typically 6, 7, 8 demonstrable chronic infections that require some sort of attention. And I wanted to get away from the the highly precise, highly individualized. Every patient gets a shopping cart full of pills and potions, to more focused, grouped remedies. And that's how I put together, for example, the foundation formula, which is just thanks to the late Steve Buhner. It's basically his core protocol that I put in capsule form. So again, I typically don't use tinctures or alcohol-based formulas. It just doesn't seem to play nice with our patients' enzyme systems, detox systems. It's an unnecessary burden, let alone the issues with disulfiram. So all of our products at this stage are dry, alcohol-free powdered formulas or powder in capsule form. And, so for example, the herbal biotic, if I can use the word, it's a broad spectrum herbal antibiotic that is suitable for the various types of Lyme, the two main families of Borrelia, but also some intracellular formulas because it contains a decent amount of Rutenia. And then also it covers yeast, fungi, and viral and biofilm. And then almost half of those constituent ingredients are anti-inflammatory, specifically in the context of an immune system that is challenged by LPS or microbial cell membranes. So again, you can give that if a patient has anything in that ballpark, that's an appropriate formula. And then you can put on top of it one of the existing formulas on the market. For example, if you feel the patient is heavier on the Bartonella side, you can use a formula that's specifically for that. Or what I did with the Cryptolepis Synergy and the Cryptolepis Concentrate is an intracellular organism specific blend. So again, if you think of what I'm talking about, if you look at the herbs in there and the ingredients, we've got Babesia, Bartonella, Mycoplasma, Chlamydia pneumoniae, rickettsiosis, things like that those two formulas cover well in the way that I formulated them. And again, the difference between the Cryptolepis Synergy is a whole herb approach. And I made an improvement to it. In the new batch that we're busy putting together right now, I added Hutania in a really high amount because that was the one thing that was missing to make it a really good Bartonella standalone supplement. And with the Cryptolepis Concentrate, it's almost the same thing, but most of the herbs are in a 20-to-1 concentrated form. So the attempt was to make something that hopefully with lower doses, you can get a better clinical result.
I love it. We need so many tools, and it's just amazing to see these products that you've put together. Tying the Return Healthy products into this conversation, are any of the products from Return Healthy helpful in the detoxification, in the DNA adduct conversation? I know you recently released the phospholipid synergy product. Might that or other tools in the line help with removal of the environmental toxicants or DNA adducts?
Yeah, we just released the final component of for lack of a better name, I call it the cell stabilization kit, which in almost all aspects mimic the IV protocol in not just nutrients, but also intent on having the cells stabilize. So it contains, I think the heart and soul of the formula is the phospholipid synergy that is put together specifically to have the necessary ingredients, the necessary specific, and in this instance, augmented phospholipids to have mitochondrial membrane recovery. Because again, most of the high quality concentrated forms of phosphatidylcholine out there, it doesn't have enough phosphatidylethanolamine for mitochondrial membrane recovery. So again, and then also what I try to do there is, TMAO as a downstream kind of microbiome dependent product. It seems like overall, as a generalized statement, phospholipids in the diet is extraordinarily important, but for some people it can actually bite a little bit. So I added some microbiome stabilizers, not just to the phospholipid powder, but also to other components of the cell stabilization kit. And then with the cell remodeling that the phospholipids bring to the table, you've got to take responsibility for what that releases, whether it's worn out, oxidized fats, lipids, or mycotoxins or toxic metals. So there's a product that is a phase 2 specific support product that we called it glutathione symmetry, that basically focus on all of the phase 2 liver enzymes. And then one of the most exciting products is the most recent one. It's a double species butyrate supplement called double butyrate. So it contains tributyrin to tend the gut immune relationship, to create an environment for an optimized microbiome. And again, so far it's been very well tolerated. I'm very pleased with it, alongside calcium butyrate for immediate systemic absorption. It's got no odor, Scott. We were able to do away with that butyrate kind of intestinal cheese curls odor. So I'm so pleased with it at this stage, and we're getting really nice feedback about it. And then for the cofactors at the cell and enzyme level, cell nutrients, if you look at it, it looks like a glorified multivitamin, multimineral. But again, I put that together for the metabolic requirements and enzyme cofactor requirements that the cells have. And then this discussion wouldn't be complete without binders, because again, once the toxins, typically more fat-soluble toxins, of which agricultural toxins, mycotoxins are part of that group, you've got to take responsibility for stirring up toxins out of the cellular milieu, supporting the step through the liver, bile dumping into the intestines, and then you do need to either flush or sequester with binders in order to decrease the amount that gets simply just reabsorbed back into the bloodstream with the normal function of bile in the digestive tract.
Amazing, amazing. My last question is the same for every guest, and that is, what are some of the key things that you do on a daily basis in support of your own health?
That's a good question. It varies. I think to some degree, I'm guilty of the mechanic drives the old beat up car kind of thing. But in my attempts, I eat well. I eat as clean as we can. Stay away from sugar is an absolute for me personally. And in terms of supplements, I do well personally with phospholipids, with adaptogens, with cell nutrients. I seem to be doing really well with the double butyrate that I'm so excited about. And then in terms of other types of habits that I've got, I do about 2 on a lucky week, maybe 3 1-hour-long infrared sauna sessions. Now that winter is not so much with us anymore, cold plunges are much more doable for me. And I try to sleep as best as well. That's a very heavily guarded from my still being at the very tail end of recovering from a 12-year bout of chronic fatigue syndrome from environmental illness. Sleep is the one thing that I guard at all costs. So I think that summarizes about what I've been able to bring to the table at this stage.
I'm a little disappointed to not see you hooked up to an IV bag. You had 2 hours here. You could have been doing some good stuff.
Thanks for that. I will take that to heart.
I usually don't ask other questions after the last question, but curious if sauna therapy over time can help to reduce DNA adducts.
Absolutely. It does. There is a British study that did an assessment of how effective are various modalities at basically helping the cells to release DNA adducts. And sauna therapy did very well. So I think it's a very important component of recovery, of exiting the CDR. And I put that side by side with hyperbaric oxygen therapy, which more and more it's accessible for the everyday person.
This was such an amazing conversation. I absolutely loved it. One of my favorite podcast discussions. I also just really value you. Not only am I grateful that you spent a couple hours with us and shared your knowledge and wisdom, but I value knowing that you're there to help people with chronic illness. I think you are one of the most highly intentioned practitioners that I've come across. I love that you still have curiosity and are constantly looking to expand the toolbox of therapies and interventions that you make available to your patients, and just really want to honor you for all of the incredible work and everything that you bring to the world. So thank you so much.
Thank you for your kind words, and right back at you, Scott.
To learn more about today's guest, visit Restore BioClinic.com. That's Restore BioClinic.com. RestoreBioClinic.com. Thanks so much for listening to today's episode. If you're enjoying the show, please leave a positive rating or review, as doing so will help the show reach a broader audience. To follow me on Facebook, Instagram, Twitter, or TikTok, you can find me there as Better Health Guy. If you'd like to support the show, please visit betterhealthguy.com/donate. To be added to my newsletter, visit betterhealthguy.com/newsletters. This and other episodes can be found on YouTube, Apple Podcasts, Spotify, Google Podcasts, and Amazon Music.
Thanks for listening to this Better Health Guy blogcast with Scott, your Better Health Guy. To check out additional shows and learn more about Scott's personal journey to better health, please visit betterhealthguy.com.